Okay, so dear participants, we have a fruitful day today, right? The exchange of good ideas, and we would kindly invite our next presenters, Iryna, Yurchuk, and Svitlana Popereshnyak, Social Networks, Analysis, Algorithms, and their Implementation. You're welcome. Let me allow sharing the screen.
Thank you very much. So, dear participants, we would like to present our result in social networks analysis, algorithms, the implementation by Svitlana, Popereshnyak, Iryna, Yurchuk. Digital side of our life, as usual, some types of networks. And collection personal data is a way to obtain additional information about person. There are several types of networks. We present solid, partial, and ego networks. Main aspects, solid networks. It's very clear to construct a group structure. Partial networks, we cannot obtain a whole group structure because there are need some more additional techniques. And the ego networks, we also there is no wall structure because we need additional information and additional information about person or such or some reason to obtain more. And in this slide, we see some example to obtain a graph networks based on some locations or information that help us to understand more structure of some data. In this example, we see the social networks. The main aim of social networks to save our old connections and to obtain new ones. And the purpose of our work is built to a prototype of software that makes us to analyze connections between nodes. As usual, the node is a person and connection is some type of friendship or kinship information. We will have two types of ties, weak and strong, and there is a hypothesis that states that if A related to B and C, then there is a strong possibility that B and C are also related. We propose to involve school or work, communities, music, photo as categories to detect ties. And in our works, weak ties correspond to 0 or 1 connection criteria, and medium 2 criteria, and strong 3 or more criteria. The main mathematical instrument for us to obtain such a graph is centrality. In short, the node that is a part of many paths between nodes have a big value. and we have to calculate value for every nodes. And we will use as software development tools RabbitMQI, Networks, and Matplotlib, some Python libraries. And there is example of a main page. And if we click on a node, we will obtain personal information about person. So if the node have such a characteristic that it's the main or central, our graph is divided into several parts. There are many clusters and all connections are removing also. And it's our example of sending data. And for this, we use methods as a way to obtain a list of friends. We also optimize our process because there are many, in many websites, there are limitations on requests, and we make it about 25. And if we have to get more information, we will try to do it from different clients, and all of them help us to obtain more. This structure of our horizontal scalable system to obtain a list of friends. As message broker, we use RabbitMQ and asynchronically distributed task viewer salary. Saving result, we will save result by Peakly because our search has a scientific character. And this example of visualization of our graph, and this there is a central node that has a very big value to join many clusters. So if we look on networks as a way to obtain information about public health, we need to remark that to use this instrument, we have to know many personal and individual data that in some reason is a limitation. So as conclusion, we have to consider the way to construct, the way to obtain a form of graph and analyze the connections between node as a persons. Thank you very much for your attention.
Thank you so much for your presentation. Questions are welcome. Okay, so if we later come up with the questions, we have talk possibilities, right? And now please, we invite the next presenters on the topic research of anti-spam bot algorithms for social networks. You're welcome. So that is Nataliia, Liubchenko, Andrii, Podorozhniak, and Vasyl Oliinyk. You're welcome.
Yeah, hi everyone. Do you hear me?
Yes.
Yeah, okay. Let me share my screen. Okay, I hope you see it now. Yeah.
It is fine. You're welcome.
So, hello, conference participants. Today I will present you an article called Research of Antispam bot algorithms for social networks. The project was created by me, Vasyl, Andrii, Podorozhniak, and Yurchuk, Nataliia. So let's make a little view on the structure of the presentation. We'll start with an introduction and the ways to deal with spam. Then we will discuss all the algorithms that have been used in our project. And finally, we will see the test results of the algorithms, and I will summarize the results. The percentage of the spam messages in the global main traffic is continually increasing. As you can see on the graphic, in 2019, it was 56.51%, that is 4.03% more than it was a year ago. Let's first talk about characterization of the spam. So spam is a mass mailing of the information to the people who have not expressed a desire to receive it. Here you can see some typical types of spam: advertisements, Nigerian emails, phishing, and so on. So what are the ways to deal with spam? The best way to deal with spam is to prevent spammers from getting hold of your contacts. The anti-spam filters help to solve the spam problem. This software has two main approaches. The first one is the algorithm analyzes the content of the message. Based on the result, it decides if the message is spam or not. And let's move to the second way. But first, I want to say that this software can only work on the server side. It classifies the sender as a spammer without looking at the content of the message. So let's make a quick view of the use algorithms. The first one is the naive Bayesian classifier. It is a probabilistic classifier that is based on the Bayesian theorem. On the one hand, this algorithm works even on the small size of the samples, but on the other hand, it works only when the assumption of the independence of the input items is satisfied. Here you can see the Bayesian theorem that the algorithm based on. The next algorithm that was used is the support vector machine. This is a supervised machine learning model that uses classification algorithm for two group classification problems. It divides the sample in two classes, and the new input will be assigned to one or other category. The third algorithm is a perceptron. It is the computer model of information perception of the brain. It consists of three types of elements: signals, sensors, and reactive elements. It literally sets the association between inputs and outputs. And the last algorithm that we have used is the convolutional neural network. The convolutional neural network, or just CNN, is a specialized type of neural network model designed for working with two-dimensional image data, but it can be used for text data as well, although they can be used with one-dimensional and three-dimensional data. Central to the convolutional neural network in the convolutional layer that gives the network its name. This layer performs an operation called convolution. Convolution is a linear operation that involves the multiplication of the set of weights with the input, much like a traditional neural network. It maps the input's data to the specific feature maps. Then, based on these maps, the result will be received. The data set for testing our project was taken from Kaggle. The name of the data set is SMS spam collection data set. On the slide, you can see the structure of the database. It has two columns. The first one defines the class of the message, and the second one maintains the actual message. We have converted spam ham class representation to 0, 1, when 1 is spam and 0 is ham. Then we have vectorized each message. Vectorization is the process of the transforming text into a meaningful array of numbers. You can see this process on the image below. Then we have removed the messages that are repeated more than 1,000 and less than 5 times. The result, the dictionary contains of 1,191 words. And here you can see the structure that we use for the perceptron multilayer neural network. The first layer consists of 1,191 inputs as the size of the dictionary, and the second consists of 64, and the third one of 16. Here you can see the results of the test on training and test samples. you can notice that the best is SVM with 98.9% accuracy of spam recognition. And here you can see the comparison of two neural networks on different samples. As it's shown on this sample, the CNN is 0.6% better than NN. This slide displays us the result of the test of two neural networks using F1 measure. And here you can see the result of the testing using F1 measures for all used algorithms. The dummy algorithm that returns always harm for every message also tested. On this slide, you can see how CNN works depending on the count of the epochs. As you can notice, 10 epochs is the optimal value for this algorithm. Here, the same for NN, but on the 10 epochs, it is overfit, so the 5 epochs is the optimal value for NN. Also, we have tested three best algorithms using majority function. We get the prediction from three algorithms, and if the mistake of the recognition is more than 5%, we don't take into account the result of the recognition of this algorithm. And here you can see the testing algorithms on training and test samples. During the research, it was considered the relevance of the spam detection and the possible way to deal with spam. The basic methods of the spam recognition were discussed. As a result of the project, it was developed the program to filter the spam messages into a ground channel. Finally, you can see the working of the development algorithms. So just
Thank you so much. Questions? Okay, thank you so much. Then we shift to our next topic, authorship, determination of natural language text by several classes of indicators with customizable weights. And we have two presenters, that is Viktor Shynkarenko and Demidovich. You're welcome.
Thank you very much. My name is Demidovich. I will share my screen and we will start. So, dear colleagues, today I want to present to your attention our research, which is dedicated to the authorship determination of natural language texts with several classes of indicators with customizable weights. Firstly, I want to tell you about few problems that we have in this area. I'm sorry. Yeah, the first problem is that now we have the absence of the technique that can help us to determine the text authorship with sufficient reliability that can be widely used in many areas. The second problem is that the linguistic features of each of the existing languages do not allow creating a universal method or tool to determine authorship. We can't use already existing methods. We need to adapt them for our Ukrainian language. And from the second problem, we get the third one, that we have a great complexity of choosing text parameters that will determine the author style properly. And here we have some aims of our research. The first one is to improve the existing results of attribution of natural language texts, Ukrainian language texts. And the second one is to select the text attributes that have the greatest information content. Now you can see methods that we use in our work. First two methods, it is frequency analysis of text, the text perception complexity indicators, and modified recurrence analysis. These methods we use to form indicators to form the text image. Next, we use the minimum distance to the standard classification for text authorship determination, and we use genetic algorithm for determining the text indicators weights. let's talk a little bit more about all of these methods. And first is frequency analysis, which is one of the most commonly used text analysis methods. And as an example on your screen now, you can see the diagram that represents the text frequency analysis of text written by Taras Shevchenko, Saul. You can see the frequency of each letter of Ukrainian alphabet that we meet in this text. Next one, it is the text perception complexity indicators. And these indicators can't reflect content and word order of the text, but we think that these indicators can be used in conjunction with other indicators. So here is a table with word frequency with different lengths in the work of Taras Shevchenko, Saul. We use words from 1, which length is from 1 letter to 15. And also to the text perception complexity, we count some more indicators. Now you can also see them all on your screens. And the third one, it is a modified recurrence analysis. We modified this type of analysis for its implication for the process of natural language texts. And it is based on the quantitative analysis of RQA recurrence plot that was used by Sbilut and Weber before. Here we take a text, it is the same text, Saul by Taras Shevchenko, and we replace each word in this text by its frequency. And in this way, we get the time series that you can see now on your screen. Then we use this time series to create a recurrence plot. You can also see this plot on your screen. And then we use recurrence analysis and count several indicators. We have 7 indicators, yeah, and these indicators help us to display some repeated moments in text and represent different type of these repeatings. After we get all these indicators, we formed the chromosome for genetic algorithm, where the places from 1st to 32nd are taken by the values of the letter frequency, which were represented in figure 1. Then the places from 33rd to 37, we have data on the complexity of the text. This data you have seen before in table 2. Places from 38 to 59, we give to the frequency of words with different lengths. It was in table 1. And from 60 to 66, we have indicators of recurrence analysis. And according to this word text image, we formed chromosome, which contains 67 elements. It is a weights of all these indicators, and the 67th element, it is the recurrence weight, the weight for recurrence threshold, epsilon. So we use Ukrainian authors' texts to form training and control samples. For training sample, we use 20 works by different authors. We take 20 works by 11 authors. And also in control samples, we have 3 works written by the same authors in it. We took only prose works up to 10,000 characters or their parts with these sites. And on your screen, you also can see the authors that we choose. What we get after as a result, after we get weights of each indicators, we can see that the most important indicators of all that we were considered is the frequencies of the letters F, Sh, Y, and Ch. Also, the numbers of words in the text with a length of 5, 1, and 4 letters, the numbers of syllables in words, and the number of letters in sentences. And for recurrent plot analysis, the most important indicators were divergence, time trapping, and entropy. And also we get result according to the authorship determination. In our previous study, the variability was 18% for analysis with character by character, and for analysis with using 4 grams, we get result 82. And now in this study, after we use these methods of weights, we use weights for all indicators, we get more good results. It is 80% for character by character analysis and 91% with 4 grams. And in our future researches, we want to expand the number of analyzed indicators and conduct research using the stems of words, and also to highlight a small list of various indicators, which combination will give the best result in determining the authorship of a natural language text for our Ukrainian language. Thank you very much for your attention.
Thank you so much for your presentation. Questions are welcome. Okay, if not, then we would kindly ask Olha Kulyna to present her topic on Anthropocentrism as implementation of a Testator, Testatrix communicative goal. You're welcome. We do not hear you as yet. Not yet, once again.
So now it's all right, yeah?
Yes, it is.
So can you see my presentation?
Yes.
Okay, I'll start with the slide. So, dear colleagues, my name is Olha Kulyna. I am from Lviv Polytechnic National University, the Department of Applied Linguistics, and it's a pleasure for me to present my paper entitled Anthropocentrism as Implementation of a Testator, Testatrix Communicative Goal. So I will start with the aim of this article. So the aim of the article was to provide the detailed analysis of verbs used in English last wills and testaments in terms of entering different lexical semantic groups, which are determined by the achievement of a communicative goal. So the following aim was to show that they are means of implementation of a testator, testatrix communicative goal within the anthropocentric paradigm. So here I wanted to show how an individual identifies himself or herself through the language and social activity. And of course, my research wouldn't be possible without the usage of a software for automated searching of certain linguistic units, MathLab, and with the help of it, I managed to establish the frequency of their usage and then to create diagrams. So I would like to indicate the corpus of the research. So the corpus of my research contains 400 last wills and testaments written in England between 1837 and 2015. So the wills written before the year 1859 were obtained from National Archive of Great Britain, but wills which were composed after 1858 were gained at the government website of the United Kingdom. So with the help of the algorithm and particularly I use the software MathLab, I was able to come to the following results. So here, with the help of this algorithm, I managed to single out lexical semantic groups of verbs in last wills and testaments written in England. So here we have 4 main groups: verbs of bequest, verbs to denote appointment of executives, verbs to show the act of revocation, and verbs for self-proving affidavit. So let's look at the results of each group. So the first group is to present the action of bequest. So here we single out such verbs as give, bequeath, direct, leave, dispose, will, advance, declare, further, devise, commit, and command. So the statistics and numbers you can see on the screen. So the next lexical semantic group was to present the appointment of fiduciaries. So here such verbs were singled out in the research: nominate, constitute, appoint, empower, vest, entitle, and assign. The third group was for to show the verbs for self-proving affidavit. And here we have such verbs as acknowledge, subscribe, set, and sign. And the last, the shortest group, it's to show the act of revocation. So here we have revoke, void or make void, rescind, annul, and disallow. So, and now let's come to the conclusions. So the research showed that English last wills and testament contain 4 communicative goals by which a testator or a testatrix implement their last wish. These goals include: the first one is the action of bequest, appointment of fiduciaries, self-proving affidavit, and revocation of a previous will. The lexical semantic group of verbs are used to express a testator or testatrix communicative goal to communicate the last will. Based on communicative goals, lexical semantic groups were singled out: verbs of bequest, verbs to denote the appointment of fiduciaries, verbs for self-proving affidavit, and as well verbs to show the act of revocation. So the next conclusion that I came to is anthropocentric verbs of speech are used and relied on established by law forms of expressions which are common for the text of inheritance law. The verbs give, dispose, and bequest are the most frequent verbs of testamentary vocabulary and belong to the anthropocentric vocabulary of speech according to the Apres-Sens classification. And of course, attention should be paid to the automated searching of certain linguistic units, singling them out into categories and created graphs presented in the article. The algorithm for extracting data from the text, preliminary data analysis, and subsequent visualization of the results in the form of graphical diagrams was implemented. Thank you. I appreciate your kind attention, and I hope I was short enough to leave the time for the following speaker, and then we can finish the session on time. So questions are welcomed.
Thank you so much, Olga Ivanivna. Thank you. Now we kindly invite the last speaker, Mariana Zhuravel and Yuri Lavriv. You are welcome. You have 5 minutes remaining. Thank you. One moment. Good. You're welcome.
So, dear colleagues, it's a great pleasure to participate in this conference. My name is Mariana Zhuravel, and I would like to present the findings of the research on methodology for analysis of intertextuality, technical aspect. So analysis of intertextuality is mainly manual for the reason that there is currently no automated system for analyzing intertext themes. And the purpose of this article is developing a software application to implement a simple and effective process of intertextuality research, including the identification of correlations between different intertext themes characteristics. For this research, modern information technologies have been applied, which allows to process a considerable amount of factual material of the investigated language phenomenon. The material for factual base was collected using the Alpha content analysis system, and the data amount 1,053 units. On this slide, you may see different technical tools that were used for the process of intertextuality research. The database was created, and some entities are built in it, such as intertext theme, origin, marker type, style, context, author, language, and so on. And the software application was implemented to interact with the database, and the developed software has the following functions. Viewing records of intertext theme characteristics, for example, information about author, context, language of origin, etc. Viewing records with all information about intertext theme based on the previously entered characteristics. A filter for displaying to the user a list of intertext themes by one or several parameters by him. And on this slide, you can see the filter for intertext themes list. Demonstration of intertext themes quantitative characteristics in the form of various diagrams. On this slide, you may see the diagram of statistics of using various intertext theme markers. Linguistic peculiarities of intertext theme analysis. The database and the program provide the full characteristics, complex of the intertextual phenomena of the analyzed array of text. The data is, as it has been mentioned before, were collected using the Alpha content analysis system and amount 1,053 units, and 871 different intertext themes were detected. And on this slide, you may see the most frequent intertext themes in the investigated materials. We also come across citations of specific authors among the research material. Some examples are presented on this slide. Furthermore, Internet users resort to quoting characters of feature themes without clearly indicating the author of the statement. It is important to note that in many cases, intertext themes aren't accompanied in the text by any marker, in particular an indication of authorship, but such information is important for analysis. For example, in this extract, the author uses lines of Levchenko, in no way marking someone else's authorship, in view of the wide popularity of these poems. Factual material analysis shows that, for the most part, intertext themes are borrowed from other languages and are used by Internet users in both original and target language. Transliterated intertext themes also come up. Some examples are represented on this slide. In many cases, such transliterated intertext themes may not be accompanied by intertextuality markers, which, as it was noted above, complicate search automation. The introduction of transliterated units into the text increases its expressiveness and emotionally expressive value. For example, this text fragment demonstrates the saturation of Internet journalism with intertext themes. The text contains the Maidan slogans "Hit is Akit Razom," East and West together, transformation of collocation Ruski Mir, Russian world, transliterated extract from the famous Soviet song, "This is a holiday with tears in the eyes."
Conclusions.
Okay, so we also observe examples of